Hello, this is Rocco Corsi, and this is the demo video for the function generator that I implemented for my final project. In front of you, you see the oscilloscope that I used quite extensively during the development. And just below it is the FPGA board from Digilent. This is the BASYS 2 board. And at the center of the board you can see the actual FPGA chip. Right now the board is off, but you can see that it is connected to the USB interface, and I'm just going to power it on and go over to my computer and program the function generator into the board. Here we go. I'm just selecting the bit file that's needed and programming it right now. And there you go. You can see the sine wave appear immediately, and here on the 7-segment display you can see that, well, it's 100 kilohertz. According to my calculations and my verifications. One thing to quickly demonstrate is that we can switch between wave patterns by using these 4 switches at the on the left side. And here you go. I'll just switch to a triangle, square wave, and here's the positive ramp and the negative ramp, and we could just go between these back and forth, and there's no glitches or anything like that, and we can switch rapidly between them without any issues. The buttons over here are used to quickly change the frequency. It's just a simple tuning mechanism, simulating, more of a knob, even though it's not really a digital a digital way of doing things. But well, that's what I had. I didn't have any other knob that I could turn, or any other kind of data input at this time. So these 2 buttons basically are to go down to 50 hertz, and when I press it, of course it's showing 50 here. This means 0.050 is 50 hertz. I have to go over to my oscilloscope here and crank it down a bit here, slow it down so you could see the 50 hertz. There we go. There you go. You can see the square waves. Let's switch between them. And here's the triangle. It's flashing because it's a refresh rate. It's a bit slow. We're at 50 hertz, so we can see the flashing here, the refreshing of the line. There you go. Here's the sine wave and the ramps. And let's go. Let's switch back and forth between them. So here we're at 50 hertz. I also want to demonstrate that there's these 2 buttons here. These are kind of buttons or switches that control the speed of the tuning. Right now they're on the slow tuning, so let's see what happens here. Not much happens because it's at the slowest speed. Let me crank it up a little bit. See if okay, it's moving 52, 53 here. Let me get my hand out of the way. It's moving rather slowly. Let me go to the maximum speed and see what happens. And there you go. And we've reached all the way to 100 and all the way back. I don't know if you're seeing this well, but let me speed this up a bit. And yeah, there you go. It's a little bit more solid now. It's really quick. Let me slow it down here at the higher speeds. We have to slow it down. So let's see. There we go. It's 166.66, 50, 40 kilohertz, 33.3, 28.57, and so on. And so on. I have to crank it down a bit here. And there we go. We're going down. And it's going to get slower and slower here, because it's kind of like the clock divider that I use is kind of a linear, it's not linear, sorry, it's more like exponential. It gets slower and slower as we're going lower and lower in the frequency. As the delay gets longer, it has this exponential effect in the frequency. Yeah, so I have these two buttons here to go quickly to 50 hertz and 100 hertz. So here's 100 hertz, and if I hit 50, then I have to crank it all the way back down. And there you go, showing you the 50 hertz. It's flashing 50 hertz. It's typical of 50 hertz. And there you go, that's a quick demo with the oscilloscope. I'll come back and just demonstrate that the frequency that I'm showing on the 7-segment display is pretty accurate when I compare it on my frequency counter. Thank you.